Okay, sorry about that, guys. My Wi-Fi went out and YouTube was quite the hassle to fix. Okay. Oh, that was really annoying. So where was I? Exponents. So the basic rules with exponents for a radical, this is the same as writing x to the 1/2 power, the derivative of x to the 1/2 power. So we would follow the power rule for that. And this is equal to 1/2. And the reason that square root of x is on the bottom is because it's to the negative power. So again, these are all just basic rules of algebra. I mean, this should be a review. If it's not, then you probably need to do a good bit of homework problems, because I'm sure that those will pound the algebra into your head. Just go through and review like some of the first homework sets if this is kind of tricky for you, because a lot of people do struggle with the algebra and calculus, and that often is the difference between a C and a B, or a B and an A, etc. So, all right, power rule, we've got that. So those are just some basic stuff. Let's start doing some problems. I know that a lot of you said you don't like fractions, so I'm going to give you guys a fraction problem to start off with. Just because we shouldn't run away from our problems, we should face them head on. So here's to grabbing the bull by the horn and non-interrupted Wi-Fi. This is problem 23 from my textbook. It's probably not in your textbook because I have a first edition, but that's not a flex or anything. I literally got it for $10. Like, it's not a very nice textbook, and I have actually had to write in corrections to it a few times, but it's been right at least 99.9% of the time. When you get to calculus 2, that's when like the computers that solve the problems kind of have a hard time with some of the more abstract concepts. But there's very few mistakes in this textbook. I love it. All right. So this right here is the quotient rule. So I'll write that out. Quotient rule. So how we're going to solve this is we're going to view the top as f of x and the bottom as g of x. So if you guys remember, the way the quotient rule works is that dx for f of x over g of x is equal to f prime of x times g of x minus g prime of x times f of x all over g of x squared. This should probably look familiar to you. If it doesn't, you might want to be a little bit concerned and start brushing up on this. It's not too bad to memorize. There's a few tricks to memorize it if you want to Google it. Like, I know a lot of Calc 1 professors use like yodeling to teach this in high schools, but I'm not going to yodel. So I'll let you guys find that on YouTube. I personally just memorized it because it's like a 2-line equation. It's nothing horrible. I mean, it's basically just derivative of top times the bottom minus derivative of bottom times the top over bottom squared. So there's a few different ways to remember it, but if you don't have a great memory and you need like a mnemonic device, then you can probably Google it, and I promise you there's going to be at least 100 of them. But let's get back to the calculus. So we know that f of x, this is a good way to start these problems, by the way. If you are not too comfortable with your algebra, it's very good to think modularly. I do it this way because I don't want to skip steps, especially when you guys are taking Calc 1. This is a class that you probably don't want me to miss any detail for. So 8x g prime of x equals 3. And the way I got that is I use the power rule here. So 2 times 4 is 8, 2 minus 1 is just x, first power is x, so 8x for f prime of x. And then g of x, 1 times 3 is just 3, and then 1 minus 1 is 0, x to the 0th power is 1, because anything raised to the 0th power is 1. And then the 4 and the -2 are constants, and the derivative of constant is always going to be 0. So this is just 2 basic polynomial expressions, and then these are the derivatives over here to the right. A lot of teachers like to organize it this way because it's good to see all the moving parts, especially when you've got a lot of algebra that you can make easy mistakes on. So now let's get into the algebra that you can make easy mistakes on. Okay. You know what? I'm just going to put this on down. So f prime of x, we've got, I'm going to write this in red so it's easy to see. I'll work all the algebra on this side of the board. So f prime of x, we've got 8x times g of x, which is 3x plus 4, minus g prime of x, which is 3, times f of x, 4x squared minus 2, all over g of x squared, so 3x plus 4 to the second power. So now what we're going to do is we're just going to work out some basic algebra. We're going to distribute these. So that's going to give us, and I'm just going to take this whole thing and move it down here so you guys can understand the progression I'm working for. So 8x times 3x is going to give us 24x squared plus 32x, then minus 12x squared plus 6, all over 3x plus 4 squared. So right here, we can cancel out some like terms. So we'll turn this, and then we'll just get 12x squared plus 32x plus 6. So I've got a hunch here. Now let's find out if I'm right or not. So I'm going to guess that the bottom here is probably going to cancel with the top, or something along that. So let's FOIL out the bottom and test this theory. So 3x, no, so probably not, 9x squared, but there are ways to factor this. And if something doesn't work the first time, then we're going to try it a different way. So now that's not going to work the way I wanted it to, because 9x squared is going to cancel with 12x squared. But what you're going to notice now is that we can divide out a 6 from every term here. Or, yeah, that would work. Yeah, let's do that. Let's see what happens that way. So then we're going to get 6 times 2x squared plus, no, 32 doesn't divide by 6. What am I talking about? Okay. Gosh. You know, the bad thing about living in an apartment is how small your whiteboard has to be. When I lived at my parents' house, I had a giant whiteboard. Right about now, I'm missing that. 12x squared plus 32x plus 6. Okay, so 3 can be divided out of all of them. There we go. 3, no. So it would look like That's going to be our final answer. And you can probably factor that some way if you want, but most teachers will accept this, if not all. This is a very finalized form of this answer. I just like to always look for better ways to factor it, because sometimes math looks nice and it actually works, but I guess this problem didn't want to factor. That is a final answer. That would be acceptable on a test. So that's just the quotient rule. Sorry guys, I have a tendency of falling down rabbit holes sometimes with derivatives because they don't always cancel, but when they do, it's really, really nice. And that one looked like it was going to cancel, but don't let something like that trick you on the test, because you will spend a lot of time on it, as you just saw. And it's often not what you want to do. So let's do some derivatives at points, because that seems to be what everyone is struggling with, finding the slope of the tangent line, correct? So let's see. All right, let's try this one right here. So we've got f of x is equal to x squared minus e to the x. And we've got the point 0, -1. So our task is to find the slope of the tangent line. And the way we are going to approach this is first by taking the derivative. So we know that, I'll just write it out like this, d dx for the function f of x equals, so power rule, 2x, and then minus e to the x. And the reason that is because, in case you guys are not aware, the derivative of e to the x is always just e to the x. It is a differentiable constant. It's very useful in differential equations. If you take that course, which if you're an engineering major, you're going to, you'll get to use this little trick here a lot more. So we know that f prime of x is equal to 2x minus e to the x. So now we want to find the tangent line of this, so I'm just gonna plug in some points. 0, 1. So our x value is 0, so that's going to give us 0 minus e to the 0th power, which is equal to -1. So mx plus b. No, this isn't. I'm going to do a better example for this one, because that's going to be confusing with that e to the x. So instead, gosh, there we go. There's the derivatives with points. So instead, we're going to do this problem right here. X squared over x minus 1 at the point -1 and -1/2. Okay, so for this, we're going to be using the quotient rule to find this derivative. So we're going to have f of x over g of x dx of that is going to be equal to f prime of x times g of x minus g prime of x times f of x over g of x squared. And I'm just reiterating this. Wasn't that -1 the slope? Not quite. It's going to be a little bit different. The reason I chose a different problem is because graphically that's going to be a little bit tricky to interpret. And I think you won't run into a problem like that on the test because I'm pretty sure you're not allowed to use calculators. So I'm trying to find more realistic problems. That was a big chapter review from an old textbook, and they used to be a lot harsher in this class. So f prime of x, actually, you know what? Let's define f of x and g of x first. So f of x is equal to x squared, g of x is equal to x minus 1, f prime of x is equal to 2x, g prime of x is equal to 1. Okay, so f prime of x, 2x times g of x minus 1, minus g prime of x, which is just 1, times f of x, which is x squared, all over g of x squared. Okay, so now we're just going to simplify this out real quick. So we're going to get 2x squared minus 2x minus x squared all over x minus 1 squared. So now there's some things we can cancel out up top. So that's going to cancel with that. That's going to give us x squared minus 2x over x minus 1 squared. So now we can factor out an x on the top and get x over x minus 2 over x minus 1 squared. And that's going to be our derivative. Or if you really want to, I guess you could. No, that would be an annoying thing to do. So now let's just plug in our points, because this right here is also going to be a nightmare to graph. But sometimes I'm just working out a few of the algebraically difficult ones first, because that's really what you guys have been sending me the most. So let's do -1, -1 minus 2 over -1 minus 1 squared, which is going to give us, let's see, -1 times -3 over -2 squared equals 3 over 4. So that's going to be our slope right there. So now we've got, if you guys remember from high school, y equals mx plus b. So this 3 over 4 is going to be acting as our m. Oh, did the video stop? It's working good? Okay. So this right here, the 3 over 4 is our slope. So now we're going to just solve for b. So we're going to do -1/2 equals 3 over 4 x plus b. So we can plug in -1 for x You get negative 1/2 equals negative 3/4 plus b. Add the 3/4 to both sides. We're going to get, we'll change colors here. We'll get b equals 1/4, which will give us the final solution for y equals 3/4x plus 1/4. So I know that was a lot, and is there any questions on this problem right here? I'll give you guys a second if you just need to take a look over your work. And then I'm going to get my phone to check the group chat as well. Alrighty, so looks like there's nothing in the group chat right now. What formula did you use to find the equation? Okay, so that's a bit of a broad question, but I used y equals mx plus b, and then this right here is called the quotient rule. So basically all I did was I took the derivative, and then once I had the derivative, if you know what the definition of a derivative is, it's the slope of the slope at the point right there, right? So we were given a point. So once I found the derivative, which was this right here, I plugged in the x value. So that gave me 3/4. Then I knew that this was a second degree problem, so meaning it was raised to the second power. So I knew that the slope of it had to be a linear function. So I use y equals mx plus b. So I plugged in my slope, which ended up being 3/4. So I got y equals 3/4x plus b. I then plugged in for y and x using the given point. I plugged in negative 1/2 for y, negative 1 for x. That ended up giving me negative 1/2 equals negative 3/4 plus b. So in order to solve for b, I added over the 3/4 to the other side of the equation. I got 3/4 plus negative 1/2. If you think about that in quarters, 75 cents minus 50 cents is 25, so that's 1/4. So I got 1/4 for b. And then my final answer for the slope of the tangent line, which is also known as the derivative. The slope of the tangent line for the function f of x equals x squared over x minus 1 was y equals 3/4x plus 1/4. Yes, those are the same. You can do either one. I think mx plus b is just a little bit more clean cut to look at. You should be able to get the same answer either way, though. So let's see if we can find another good one, because those are actually not as common as you would think, those problems at a point. The textbook just doesn't like them at all, but I know that the homework stuff that you guys use is probably giving you a bunch of problems like that. So I'm going to try and find some. Let's see. So I'm just going to leave this up for a second while I look for the next problem to give you guys. And then, let's see. All right, you know what? I actually have the ability to make these problems off the top of my head, and I just thought of a great one. So the way that you can make these problems up is by knowing what the graph looks like. Because I know a lot of people, and this, even myself in my earlier days tutoring, when I would try and make up problems for calculus, was a little bit tricky, but I have been doing a lot of calculus recently, so I think I'm feeling pretty froggy. Let's jump. So let's start with a graph, why don't we? All right, I'll start with the function f of x equals x squared minus 2. So now, a lot of you have a hard time graphing this stuff, and if you do, I would say you should use a table, because I think this is probably the easiest way to graph something. Or if you know the shape of this one, we can also just think of it as a parabola, right? So we go, let's see, x squared minus 2, so I'll plug in a few points, right? 0, so 0 minus 2, the y value is going to be negative 2, right? So then if we plug in 1, x has 1, 1 squared is just 1, that's going to give us negative 1. If we plug in 2, then we're going to get 4 minus 2, which will just give us 2. So let's start at our y-intercept then, 0, negative 2. So that's going to be right here. 1, negative 1. So that's going to be right there. 2, 2. Right there. And now we have a general shape of this parabola. And we kind of know what we're looking at, because we know the parabola is going either ways. If you guys know your geometry, then I'm sure that wasn't fun to watch, but because you can just follow the basic rules there. And if you can follow it by knowing that that's a vertical translation downward. So let's look at some points now. The reason I drew out this table is because I really want you guys to get like a bare bones understanding of this. So we've got 1, negative 1. So if I ask you to find the tangent line for f of x at the point, we'll call this P, then the first step we would do is look at our points. We've got 1, negative 1 right here. I'm going to redraw my parabola so it actually goes through that line there. Like I've said before, I'm not an artist, but I do like math. So 1, negative 1, our point P, this, we'll call it P. So if you guys remember how to take a derivative, it looks something like this. F prime of x equals 2x for the function f of x. And now if I ask you to find the slope of the tangent line, do something like this. So y -1 2 plus b, and this is just mx plus b form, -2 b equals -3. So now we're going to get y equals 2x minus 3. So let's try that. Let's graph that one. So this is 1, 2, 3. So if we do our x and y tables, we'll know that our x-intercept is, or our y-intercept is going to be -3. So this is that And then our slope is going to be 2 minus 3, so 2 up 2 over 1. And if I could draw a straight line, you would realize that this right here is the slope for the point that. So this right here is for y equals 2x minus 3. This right here is for y equals x squared minus 2. So sorry, that's a really, really bad drawing, but I think this is probably the way we should approach this session. Just break it down, make it look effortless, like Bob Ross style. That's what I'm feeling today. Yeah. Let's do some Bob Ross math here. That's definitely the move. I'll put some more effort into my drawing so it's a little bit nicer to look at. So I'm gonna leave it up for a few more seconds and it's gone. Yeah, that seems like the right way to teach this. Break it down into math so easy that even a middle schooler could do it. And in case you're wondering, I actually have tutored an 8th grader in calculus, and he can do pretty much everything up to integration. Someone said the green was good, so I'm going to use black for this one. Okay, so f of x equals, what's one that isn't too hard to graph? Let's say 2x squared plus 4x plus 1, something like that. So now, if we want to graph this, we can plug in a few points. So if we plug in 0 for x, we'll get the y-intercept. It's just going to be 1. If we plug in 1 for x, that's going to give us, let's see, 2 plus 4 plus 1, 7. If we plug in 2 for x, that's going to give us 2 times 4, which is 8, plus 8, so 16 plus 1, 17. And that should be enough for us to get a general idea of what this is going to look like. So it's going to look something like this. This 217, 1, 7, 0. So now what we're going to do is we're going to find the equation for the tangent line at the point P. So we're looking at 1, 7 here. So we know that if f of x equals 2x squared plus 4x plus 1, then f prime of x is going to be equal to 4x plus 4. So we know that the slope of our derivative is going to be 4. So now let's put it into y equals mx plus b form. So y equals 4x plus b. So now let's take our point 1 and 7. So we got 7 equals 4 times 1 plus b. So now we got 7 equals 4 plus b. Subtract 4 from both sides. We'll find out that b is equal to 3, which gives us tangent line formula of y equals 4x plus 3. So why don't we test this? So 3 up, 1, 2, 3, 4. 3 plus 4 is 7, and then over 1. So yeah, I would say that works. Wait a minute. Wait just 1 minute. 0. Yeah, that works. I just can't draw a graph to save my life. X plus 3. Does anyone have any questions on this? Like, am I moving too fast? Is this all pretty straightforward? You know what? I think I made a mistake here, actually. It just doesn't sit well. So let's try this. So we plug in 1 for x. That's going to give us 4 plus 4 plus 8. So 8x plus b plus y. 7 equals 8 plus b. B equals 4. So y equals 8x minus 1. There it is. Okay, I did make a mistake. I knew it. Yeah, so here we go. My apologies, guys. That makes a lot more sense. I knew something was off there. So when you get the derivative, you know what? Let's write this out by steps. So y equals 8x minus 1. I'll put that for the tangent line here. So the way we approach this is step 1. Take derivative of f of x. Step 2. Plug in x coordinate. Plug in x coordinate into f prime of x. Step 3. The number you get from plugging in x is going to be the slope. So use step 2 answer as m for mx plus b. Position, velocity, and acceleration in the session. Yes, I can actually. That's actually a good segue. But I'll finish this first. So step 3, use step 2 answer as m, so mx plus b. So then when we get that far, we take our final formula, which we take 8, so we get y equals 8x plus b. We know our x value and our y value. So we have 7 equals 8 plus b. So then b must equal -1. So our final answer for the tangent line is 8x minus 1. Is there a different slope for each position? Yes, there is. The slope at 0, 1 would be 0 because there is no slope. The slope would be different here, be different here, different here, and different here. It can be a bunch of different positions. That is why calculus is interesting, which also relates to Anthony's question about position, velocity, speed, and acceleration, because this right here, well, here, let's take a problem. I'm not a big fan of physics stuff, but I do like the math in physics. I have taken up, I think, every math class required to be a physics major, but I have not taken physics 1 yet. So I'll be taking that in the fall, but I do know how to do all of the math in physics. So at least at Kennesaw, not in all of physics. I'm not implying that by any means, because physics is a giant field. Okay, here, let's take this one right here. This is a great problem for this example. And by the way, guys, if you're good at math, you're good at physics. Like, the two should go hand in hand. If you get really good at calculus, then physics should be a breeze for you, because physics is basically calculus with a bunch of symbols in it. Vector calculus, differential equations, etc., etc. So let's see, we've got the height in meters of the ball above the ground is approximately, so this is our expression for height, S of t equals negative 4.9 t squared, in which t is representing time, of course, plus 29.4 t. So where t is the number of seconds that elapse from the moment the ball is released, what is the velocity of the ball at time t when t equals 1 second? So if we view this right here, S of t, this is our expression of height, right? So height. A lot of you are going to take Calculus 2 next year, and you're going to learn that you're doing all of Calculus 1 just backwards. And these problems are going to be very strange when you come back to them. So then we've got height. This is the hierarchy right here. Height, velocity, acceleration. So if we take the derivative of the height function, s prime of t, that's going to give us our velocity. So we're going to get, let's see, negative 2 times 49, so 9.8 t plus 29.4. Then if we take the second derivative of this, s prime of t, it will just give us negative 9.8 as our acceleration. So the first part of this question asks, what is the velocity of the ball when t equals 1 second? So we will use second equation here for velocity, which is just the first derivative of height. So if you want to think about it this way, you can think of height as f of x, velocity as f prime of x, and acceleration as f prime of x, f double prime of x. So what we have here is actually a pretty nice situation, because we already have all of the math done for us, so now it's just kind of plug in and play. So velocity, negative 9.8 times 1, because they want to know what it is when t equals 1, equal to negative 9.8 plus 29.4. So let's see, 20.4, 19.6. Someone double check me on that. This is our velocity at t equals 1. And of course, guys, what does this mean? It means our acceleration is constant, because here's something to wrap your head around. I know there's got to be at least one person in here who thinks they want to be a physics major. So I'm going to blow your mind. So ready for this? So this is a ball being thrown in air, right? It's a parabola based off of time. So the velocity is that, right? But then what you'll notice is the acceleration is a constant term, and that's because gravity's acceleration is negative 9.8 seconds, feet per second, something like that. It's basically just saying that the acceleration is gravity, which would be the same for any free-falling object. So I'm pretty sure this is as much physics as you'll ever see on one of these tests. I mean, this is as complicated as it gets. If they give you something for height, take the derivative once, get the velocity, take the derivative twice, get the acceleration, and then all of the other problems, it's just a matter of plugging in a value for t. So I'm gonna do one more problem here just because that interruption, which was quite annoying. So let's do, ooh, this looks fun. This is like a proof problem. This is good for some people that enjoy math. This is good for anyone that wants to learn what this stuff actually does. Because if you can't prove it, you can't use it. So let's see. He also found that all falling bodies obey the law stating that the distance s they fall when dropped is proportional to the square of the time t it takes to fall that distance, and that the constant of proportionality c is the same for all objects. That is, s equals negative c times t squared, in which s is distance. So then the velocity is going to be equal to the derivative of s with regards to t. The letter that's on the bottom, that's the one that you're taking the derivative in regards to. So like a lot of you have probably seen dy dx, which means take the derivative in terms of x. But in some of the homework problems, you might have seen something where it's like dx dy, which means take the derivative in regards to y. So we're going to be differentiating s in terms of t. So that's going to give us negative 2 times c times t for velocity. And what do you know? It's correct. So then acceleration is going to be the derivative of that. We'll mark that with a, which is going to be equal to dv dt, which is just going to be negative 2 times the constant c. So negative 2c is a constant. Usually we denote 2c by g. So we know that c equals 1/2 times gravity. The number g is called the acceleration due to gravity for our planet. Okay, here's those numbers that I was blundering earlier. So 32 feet per second squared, 9.8 meters per second squared, or on the planet, oh, this is a fun fact here, on Jupiter, gravity is 26 meters per second squared. So this is all of the physics you need to know for this class right here. I wouldn't worry too much about it. So now let's do, I don't know, let's do a hard derivative just to finish it up. I wanna choose something kind of fun. And I'll work it out. You guys can just follow along, and then I'll do it with my best handwriting that I have. I'll just do a quick little introduction to something. So I'll do a chain rule problem. That's what I'll do. Let's see. I don't know. Let's do something kind of fun. F of x equals the square root of sine of x. I don't know. That's kind of fun. So now the chain rule, we can say that f of x equals root x, g of x equals sine of x. So thus, f of g of x equals the square root of sine of x. So now if you guys remember, the way we take the derivative for something with the chain rule is like this. F prime g of x times g prime of x. So what that would look like here is we can rewrite f of x as an exponent, which every time you see a radical, I would recommend you do that. So then we know that f prime of x, we'll take the derivative of the outside first. So 1/2, keep the inside the same, sine of x, the negative 1/2. And then we multiply by the derivative of the inside, which the derivative of sine is cosine of x. So now this is going to give us, for our final answer here, this nonsense, but not a lot of professors would accept this, so I'm going to show you guys a new way to write it. We're going to keep the cosine of x on the top. We're dividing the whole thing by 2, and multiplying that 2 by the square root of sine of x. So this is just the basics of the chain rule, you know, take the derivative of the outside, multiply it, or take the derivative of the outside, keep the inside, multiply by the derivative of the inside, which is exactly what we did here. If you see a radical, you're going to want to change that to an exponent. Like something you might run into later on in this class is going to be something like this: cubed root of x minus 2 squared. What you don't know is that you can actually write this as just x minus 2 to the 2/3 power. Yes, the bottom could also be 2 times sine to the 1/2 power. That would also be an acceptable answer. Because it's equivalent. I mean, think about it. The square root of sine of x is the exact same as writing sine of x to the 1/2 power. Because what that says is that it says you're raising it to the first power and then taking the second root of it. So whatever power you're raising to, you're going to put on top of the fraction, and then whatever root you're taking, you're going to put on the bottom of the fraction. So yes, that is absolutely an acceptable answer. So, is that a fun problem? That looks like it could be. No, that's kind of the same thing that we just did, except less complex. If everything in this video that we've gone over has made sense and you were able to follow it very easily, then you should feel quite well prepared for the test. I mean, Professor Kang sent me an email, and for tomorrow's session, or not tomorrow, Saturday session, right? Yeah, Saturday session, but he sent me an email with some topics and questions that will be on the test. Today, I kind of just wanted to go over a review real quick, just do some last minute problems. The next session is really going to be the big one. I mean, this stuff right here shouldn't feel that difficult. I'm trying to hold back because we're really going to go at it in the test review. But if you feel comfortable with this, then you should feel comfortable going into the test. If everything here has made perfect sense, just make sure to know trig stuff, algebra, like mx plus b, really, guys. The tangent line, that's like all you need to know. Like you just take the derivative of whatever f of x is, you plug in that, and sorry about that earlier, like it was just kind of, I haven't had my coffee today, but you take the derivative, you plug in the x value, that's going to give you the slope for y equals mx plus b. Then you just plug in the points for y and x, you solve for b, And then that's all there really is to it. I mean, I thought that the major review was tomorrow. Yes, it is tomorrow. I misspoke. That's right. I said Saturday. I mean, yeah, that's my bad. I know the test is on Saturday. That's right. Yeah, that's what, okay. Yeah, major review is tomorrow. That was my bad. From noon till 2 p.m. So tomorrow I'm gonna have probably 20 questions prepared. I'll send them out to the group chat an hour in advance or so. If you want to start working on it beforehand so you have questions prepared for the session, then that's perfectly fine. But what I'm going to do tomorrow is every question that I'm going to go over, I'm going to give about 5 minutes time. I'm going to try and set up something with Microsoft Teams so we can kind of interact in live times, but I've been having a lot of technical difficulty with that stuff. I mean, Microsoft Teams is kind of hard to use with YouTube Live without crashing my really bad internet connection. But yeah, I'll see you all tomorrow at noon. I hope this session was helpful. I'll have a lot of problems prepared for us tomorrow. And if you need any help tonight, feel free to let me know. Feel free to ask anything. I'll be able to shine some light on whatever it is that's causing you a lack of clarity. So appreciate y'all for coming out today and have a good night.